Kia ora Year 11, here's the very last couple of videos before tomorrow's exam. So these are for Sahisnu, who emailed me yesterday morning with a couple of questions from the March 2020 paper where my word solutions didn't make that much sense. So I'm going to do the whole of this trig question, even though it's only the last bit that is a little bit confusing, because chances are someone else out there might benefit from it. So if we look at that first one, we can see that we've got a quadratic equation and it's in tan instead of just in x. And we have to solve that equation for this range of x values. So what we're going to do is turn that into a straightforward quadratic by letting u equal tan x. And then we're going to solve for u, and we're going to go from there and solve for x. And we're going to draw a graph straight away of the tan function. So the tan function is a very bad tan graph, but there you go. The tan function has asymptotes at 90 degrees and then at 270 degrees. But the bit that we're interested in is between 0 and 180. Okay, so my quadratic turns into this, 3u squared minus 5u minus 2 equals 0. Now the 3 and the 2 are primes, so I can factorise this one pretty easily. So I get 3u here and u here. We want two numbers that times together to give me, take away 2. And end up giving me minus 5u in the middle. So let's try minus 2 here and plus 1 here. Right, so that works. So we get u equals negative a third, or u is equal to 2. We swap it back out to tan, so tan of x is equal to negative 1/3, and tan of x is equal to 2. So the first thing we try is just tan inverse of negative 1/3, and we chuck that in our calculator. That gets me negative 18.4 degrees. So that's not in the domain that we want. So what we're looking at up here on my tan graph is a horizontal line here at negative a third, and the value that we've picked up is this one back here. But if we add on 180 degrees, we get a solution, right? So x is equal to negative 18.4 plus 180 degrees, which gives me 161.6 degrees. So that's my first solution. Now, happily, when I do tan inverse of 2, I get a solution which is in my domain. So that gives me 63.4. Now, let's look at our graph and see if that looks right. Well, we've got one line that I've put on at negative a third, and then I've got another line up here at 2. And so that lets me check how many solutions I've got within that pink domain, right between 0 and 180. So here's my second solution at 63.4. Now this is useful because in the third part of the question, what we have to do is to figure out how we can change that equation a little bit to get 3 solutions in this domain. Okay, and you can probably just about see what I'm doing there. But we're going to do, we'll do 11b first. Right, so find the set of values of k for which this equation has no solutions. So the only thing that's changed here is that my constant is now something that I have to solve for. As soon as you see no solutions, you should be thinking about the discriminant. So we want 3 tan squared x minus 5 tan x plus k equals 0. So for no solutions, we need the discriminant to be negative. So what is that discriminant? Well, it's going to be 25 minus 4 times 3 times k is negative. So 25 is less than 12k, which gives me, let's go slowly. Let's divide both sides through by 12. So 25 over 12 is less than k. But it's nicer to write that as k is greater than 25 over 12. So there we go. So for any constant above 25 over 12, that equation will not have any solutions. Okay, so now onto this last part. Let's get rid of some of this. So for this equation, we have to figure out what value of k is going to give me 3 solutions. So I think it might be worth drawing a new tan graph and a slightly nicer one. So let's use a ruler. Crazy idea. Don't forget to take your rulers tomorrow, guys. So there's a ruler there, And let's chuck in the axes. So the axes are in the purple. Now we'll use sparkly pen for the tan graph. So the tan graph looks like this. And we're only interested in the bit between 0 and 120. So I'm just going to draw that bit in. Right, now I've got a quadratic, right? And so what I'm going to get to with my quadratic is at most 2 factors. Something times something equals 0. So looking at that graph, what we saw before when we had this one up here is that we had one factor that was giving me a line like this, right? And that was generating one solution. And then we had the other one down here, and that was giving me one solution like this. So how can I possibly get 3 solutions? So I think this is a really nice question because it links up the ideas about quadratics, but also about how valuable a graph is to us. So I can get 3 solutions, but the only way that's going to happen is if one of them is giving me the 2 endpoints, because there are 2 places between 0 and 180 where tan of x is equal to 0. So that's the key to doing this question. When will I get 3 solutions? Tan x must be a factor. Right, so now we have to go ahead and rewrite the equation with a k value that gives us tan x as a factor. So tan x must be a factor. So how will that happen? Well, let's look at what happens if we make k equal 0. So 3 tan squared x minus 5 tan x equals 0. And now we've got tan x times 3 tan x minus 5 equals 0. Okay, so that's how we're going to generate 3 solutions. So let's solve it now and get those solutions. So x is equal to tan inverse of 0, which is 0 degrees, and x is equal to tan inverse of 0 plus 180 degrees, which is still in my domain, right? So there are 2, and then the last one comes from tan x is equal to, what have we got? Tan x is equal to 5/3, so x works out to be 59 point something degrees. Okay, so that's how we get our 3 solutions. So there you go. That's all of that trig question done. I'm going to do your coordinate geometry one in a few minutes. Thanks for watching, and everyone remember, good luck for tomorrow. No point working too late tonight, so it's probably nearly time to stop studying.